Hello all, Dr. Hassan is here with my second video on Arduino. So the second video covers a little bit more than basic. So in the first video we turn on LED light, we program it to flash. This time I want to use the ultrasonic sensor, which is going to be a motion sensor. Then based on actually calculating distance, I like to make a decision. So in my case, what I have in my mind is that I want to use the sensor to read the distance. So how it read the distance, it measure the time. So it send two signals, right? So one signal trig. So if you look into ultrasonic sensor, has VCC, trig, echo, and GND. This is the 4 pins on ultrasonic sensor. Now the VCC and GND are simply to power up, right? Any sensor needs power to work. Then we have the trig send the signal, echo get the signal back, right? That's how we measure the time, and then from time we can calculate the distance. Again, same concept how ships, they calculate depth of ocean. So they send a signal, they measure the time for that signal to come back. So in this case, if the distance is less than 10, I want to turn on the LED light. So this is the concept I have in mind. I like to create a circuit. I like to program it in Arduino software and make it happen. Before I begin, so I like to a little bit talk about the Arduino boards again. So Arduino boards has, I have digital signals in one side from 0 to 13, like turn on, turn off. In this case, trig and echo, both of them are digital signals. A0 to A5 are analog in the other side. And then the only thing that I have done so far, I got two wires. I connect the 5V to the positive and then the GND to negative. So what I did, I actually moved the electricity from the Arduino into our board. So our board has electricity. I'm going to need electricity for multiple reasons. I need electricity for this thing to work. Again, remember on your ultrasonic sensor you have a VCC. Again, in my case, I already connect them with 4 wires. Again, you can actually punch them in. But again, I'm going to follow them by color. I know the red one is VCC in my case. So VCC means 5 volts. So I'm going to just simply punch it into the positive one. So I'm going to a little bit separate these wires from each other. So allow me to play with them. So this, I'm going to move the VCC. I'm going to plug the VCC to the positive, the GND to negative. So far, I'm sure that my sensor has the power to work. So the trig and echo, I need to make a decision where to connect them. So I know trig and echo, they need to go to digital. I need to select a pin. In this case, I'm going to select pin number 13 for trig, pin number 12 for echo. So remember, these two are in our digital side. So side of the Arduino. So I'm going to go to the digital side, find pin number 13 and then pin number 4. Again, just follow the color. Orange is the trig. And then the yellow is the echo. So I'm going to connect the yellow to number 12. And then connect the trig to number 13. Hopefully all are good. So 12, 8, 9, 10, 11. Perfect. So for the LED lights, I need to make a decision again. Right now, if I write the code will be able to give me the distance, right? Before I move on, I like to a little bit complete the circuit more. So for me, if the object came close, less than 10 centimeter, I said that turn on the LED light. Okay, LED light is connected to what pin? So I'm going to use pin number 11 on the board. So I'm going to use pin number 11 for the LED. Pin number 11 for LED, number 13 for trig, number 12 for echo. So let's get started. I'm going to create a circuit here. Again, you need a resistor and then the LED light. But remember, LED light has a longer leg. As we discussed in the other video, the longer leg is the positive leg. That's where the signal needs to go in. So keep in your mind where you punch them in. So I punch them like this. I know the longer leg is in this side. Then make sure that where you put the LED lights, again, one side of the LED light, the shorter leg needs to be connected to resistor. So in order to do that, I'm going to punch in the resistor on the same row as the LED light, as the shorter leg of the LED light, and then the other side doesn't matter where. Okay, I'm going to grab two more wires. One wire connect the leg of the resistor to the negative, and then the other one should go to number 11. Okay, before I move on to number 11, I just want to make sure that my circuit works or not, right? So just to make sure the circuit works, I'm just a little bit longer wire. So I'm going to connect the longer leg of LED to positive for a second, just to make sure the circuit is okay. You can see the circuit is working, right? The LED turned on, meaning that my circuit is closed and complete. So instead of coming from positive, it has to come from number 11. So let's move on to the circuit, punch it in number 11. So let me just to move up and show you exactly how the connection look like. So the longer leg of LED is connected to row, again, connected to, in the same row, connected to digital 11. The shorter leg of LED is the same row as the resistor. The other row of the resistor is connected to the negative. Again, watch the other video to see how we connect the LED light to the circuit. So now I want to go to the program and start manipulating the program. So in the program, I borrowed the code from online. Then the code I have is simply for a simple LED light. Okay, that's the code I have. In the code, you can see define trick pin number 13. This is just a variable. It was introduced for, again, we call them trick pin, echo pin, and LED. So we use pin 13, 12, and 11. In the top, we have the setup. So in the setup, we have three setups, right? Pin number 13, 12, and 11. So 13 will be connected to trick. So, and then again, trick is an output, echo is an input, right? So you send the signal through trick, you receive it through echo. Then we have the LED, which will be output. On the loop, the code up here actually calculates the distance and the duration. So what it does, it actually send the trick pin, it sends it every 2 milliseconds, and then get it back in another 2 milliseconds. So you are actually keep playing with it. Then the code here, after we found the duration, in millisecond, you can actually calculate the distance with it. Again, duration divided by 2 because you have the time to go and then the time to come back. We divided by 29.1 to measure it in centimeter. But again, this needs to be lots of correction done. If we calibrate our sensor later on, we can change these numbers. If the distance is less than 10, digital write LED high, and then else other than that, make it low. And also print the distance for me and show it to me every 500 millisecond. 500 millisecond meaning that every half a second. That will be like too much. My eyes cannot catch it. I'm going to change this instead of, I'm going to make this to 2000. So every 2 seconds give me a reading. So I will paste this code on my weblog, which is drnam.org/Arduino. You can actually go to that website and then get the code from it. So that will be there on the description. I'm not sure whether I can put this or not on the video description. Sometimes they don't allow you to put code in there. So going back to Arduino, all I need to do, I need to load this into my board. Remember that you have a serial print down here. This is going to give me a printout of the distance that we can use it for calibration and further analysis. I'm going to show you where to watch that. So before I move on, I'm going to compile the code. The first check will compile the code for me. So if there is error, it's going to pop up there that you have a syntax error or other types of error. Okay, compiling, done compiling, no error. The next one is to upload this to the board. Before you upload, make sure to check two things. First, make sure the board is Arduino Uno, and then select the port. You see, the port keep changing once you unplug. So I'm going to select COM5, which is Arduino Uno. So all good. Then click on the arrow. So this will send the program to the board. So I'm going to go back to the board to see what is happening. So things look normal on the board. I bring my hand in front of it. Again, I don't see any reaction from it. So let me go back to the code to see what is happening. So it gave me an error. An error occurs while uploading the sketch. So let me retry this again. So I'm guessing due to the problem is for the upload. I'm going to unplug it from the unplug it and plug it back again. Maybe unplug it from this side. Okay. Go back to Arduino. Then when I plug it in again, I'm sure the port didn't change. So let's upload it again. It's done uploading. Right, this time worked. So by unplugging and plug it in again. So let's go back here. If I bring my hand in front of it, the LED turns on, right? Because the distance is less than 10. Once I remove it, it turns off. Again, I like to do a little bit more analysis on this. I'm going to go back into Arduino. In the Arduino, you can go to Tools, and then you can need to go to Serial Monitor. Serial Monitor will print, like right now, the distance is 191. This is actually the height of ceiling in my room. If I put my hand in front of it, again, the distance came to 20 centimeter. And then if I make it closer or higher, the distance will keep changing, right? Now I have a ruler with me. I can actually measure exactly what this guy is talking about, right? So I'm going to put the ruler in between of these two lights so it doesn't have any interfere with those. The length of this ruler is 15.5 centimeter. I put again something, not my hand, something which is more, again, because the signal can go through my finger. I'm going to put something like this on the top of it. So let me go back to the measurement and show you what I did. So I put a ruler on it and I put the object on the top of it. But I believe this one, based on what I see, is like 16 centimeter, 15.5 centimeter, based on what I have. So going back to the code showing like 16, right? So again, I have to make sure that I don't move my hand. It's 16, 17. If you see something wrong on your measurement, you can actually go back to the code and correct it. So in the code, you can go back to the code where we have divided by 29.1. You can change that to a ratio that's more appropriate. Like for instance, in this case, instead of 29, could be just simply 29.5, right? If I upload it again, you can go and try with ruler to make sure the distance is okay. And my code is working very well, right? If the distance is less than 10 centimeter, turn the LED light high. So sometimes you want to have like more loops in that. If less than 10, do this. If more than 10, do that. So you can actually create more loops, use more nested if, right? So within this if is less than, again, if less than 100, let me make a little bit changes. It's less than 30, make the LED light turn on. Within that, I can have another one. So I'm going to say, for instance, I'm going to copy the same code and create a nested if inside that. If the distance is less than 20, I'm going to call this one LED2. Okay, turn on the LED2. But you have to make sure that your if is inside the other if, right? That's why we call them nested if. So I'm going to copy this and put it down here. If less than 10, turn on the third LED light. LED 3. So remember, I added LED 2, LED 3. The computer code doesn't know what these are unless I go up there and define them, right? So I'm going to define I have LED 2, I have LED 2, and I have LED 3. I'm going to punch in the light for LED 2 in number 10, punch the light for this one in number 9, and then I need to also define them as an output in the setup. Again, I make the necessary changes. So, and then paste one more time. So this is going to be LED 2 and LED 3 are output. Now I have, if the distance less than 30, the LED going to go high. If this less than 10, the other LED. And then, so I'm going to just make sure that things are okay in the code. So then in down here, I need to repeat that too, right? Otherwise, if this is not happening, make sure that you turn on all the LED lights. Again, I may need to go and repeat that. Like my code may malfunction basically based on what I have, but this is just a trial, right? So number 2 and number 3 here. Go back to the wiring on the Arduino. I need to introduce 2 more LEDs. So I'm going to find 2 more LEDs to bring in. I'm going to bring a yellow one and a white one. I need 2 more resistors. So let me find 2 more resistors. And I need to wire them up too, right? So let me get the 2 more resistors. One here. Again, I'm repeating the circuit that I have up there. The longer leg of LED is going to be here. Okay, remember this is the second one. And then the third one, I'm going to put it here. Bring my hand in front of it so it knows it's an object. So a bunch of wire is needed to connect the shorter leg of resistors, shorter leg of LEDs to the negative. Okay, this is going to go to negative. I'm going to borrow another one for this resistor, put that in negative 2. In order just to make sure before I plug them to number 9 and 10, just to make sure that things are okay, I'm going to just try it to see whether the circuit is closed or not. So before I punch in number 10, I'm going to punch it in the positive. Yes, that LED light is working. So I'm going to put this one in number 10. The next LED light, I'm going to put it in number 9. 9, connect to here. Again, I made the corrections, then the required connection into here. So let's upload the new code in there. Okay, again, before you upload it, make sure the Arduino Uno, the COM is connected on the tools. So I'm going to compile it for errors. Okay, no error. That's the good news. Now the new code is uploaded. It's still uploading. Done uploading. Let me just to go back in there. So I'm going to bring my hand in front of it to less than 30. You see all 3 of them turn on. So there could be something wrong in my code. I can just go back to serial monitor and then check the distances. So distance right now is 16, is 200, right? So the thing that make this read wrong is because of the object, which is my hand. I'm going to use this one. So let's see what's happening. Okay, so this is less than 30, less than 20, and going to it less than 10. Then when I remove it, all three of them should turn off after a few seconds. But again, the code is working. It's a good code, right? 30. Again, you maybe not be able. I cannot put it in my camera. I got closer. The 20. This is less than 20, and I get closer. This is less than 10. I remove it. All of them turns off. So again, you can do whatever you want to do with it. And then in the next video, I want to show you if the object came close, how you turn on a motor with it. Okay, thank you for watching this video.